Hello everyone. In the today's session, we are going to discuss some important questions and PYQs of the chapter Electricity. Let's get started. First, as usual, let us solve some MCQs here. Let me read the first question. On which of the given factors resistance does not depend? And the options are length of the conductor, area of cross section, temperature, density. We know that resistance of a conductor is given by the equation R is equal to rho L upon A, which means this resistance is depending on the length of the conductor, area of cross section, and this is constant for a particular material. Now we know that resistance is also depending on the temperature. Here the question is, we should choose that option which does not affect the resistance. Means the resistance does not depend on which factor here. We know that it is depending on the length of conductor, so this is not our correct option. Area of cross section, this is also not the correct option. Temperature, we know that resistance is depending on the temperature, and the density is the factor on which resistance is not dependent on. So our correct answer is density. The next question is, a cylindrical conductor of length L and uniform area of cross section A has resistance R. The area of cross section of another conductor of same material and same resistance but of length 2L is. Here they have given two conductors which have the same resistance, but the length and area of cross section are different. Now we have to find out the area of cross section of the second conductor, that is another conductor here. Let R be the resistance of both the conductor. As they are same, I have taken it as R only. We know that the resistance is given by the formula R is equal to rho L upon A. For the first conductor, the length is L and area of cross section is A. And for the second conductor, the length is doubled. So we will take it as 2L, as they have given the length is 2L. Then we have to find here the area of cross section. Let A2 be the area of cross section of the second conductor. As we know that both are having the same resistance, let us equate these two equations. We will get rho L upon A is equal to rho into 2L upon A2. So these rho L and rho L will get cancelled. So we will get A2 is equal to 2A, which means the area of the second conductor it is equal to 2 times that of area of the first conductor. So the right option will be B, that is 2A. In the following diagram, the position of the needle is shown on the scale of voltmeter. The least count of the voltmeter and the reading shown by it respectively are. We have to find here the least count and the reading shown by the needle. Here the value of the voltmeter which it shows, we have to find out that. You can see here 10 divisions is equal to 1.5 volts. 10 divisions is equal to 1.5 volts. What is the value of one division? It is given by one division, or it is least count. What do we mean by least count? It is the smallest value that this voltmeter can measure. It is equal to 1.5 divided by 10. It is equal to 0.15 volts. So each division on this voltmeter has the value 0.15 volt. Now the voltmeter reading at this point is 1.5. After this, there are still two more divisions that voltmeter is showing. This implies that the value will be 1.5 plus 2 into 0.15. Why I have taken 2 here? Because there are two divisions and each division has value 0.15 volt. So I will get it as 1.5 plus zero point 0.3 which is equal to 1.8 volt. So the correct answer will be the least count is 0.15 volt and the reading shown by this needle is 1.8 volt. Let us check the answer here. So this option C is our correct answer. 0.15 volt and 1.8 volt. The next question is a student plots VI graph for three samples of nichrome wire with resistances R1, R2 and R3. Choose from the following the statement that holds true for this graph. Here the graph of I along y axis and V along x axis is given. What does the slope of this graph give us? The slope is equal to I upon V. We know that slope is equal to height upon base. And what is this value gives us? It will be the reciprocal of resistance. We know that R is equal to V upon I. But here we have I upon V. So it is equal to the reciprocal of R. This gives us slope is equal to 1 upon R. So for this graph, the slope is inversely proportional to R. More the slope, lesser is the resistance. Less the slope, more is the resistance. You can see for all these different resistances, for all these different graphs, here it is having more slope, which implies this having the least resistance. And for this R2, it is having the least slope, but it will be having more resistance because of this relation that we have got for this graph, as they are inversely proportional. The slope of R2 is least. Because of that, the resistance will be the highest of all three. Then comes R1 and the last will be R3. It is having the lower resistance as it is having the highest slope. So the order of resistances will be R2 greater than R1 greater than R3. So the correct answer will be R2 greater than R1 greater than R3. This will be our correct answer. You have to observe the graph carefully, whether I is given along the y-axis or V is given along the y-axis. In case V is given along the y-axis, then slope would be equal to R. Then that case would be different. But here the slope and resistance are inversely related. You have to observe this carefully. The next question, the maximum resistance which can be made using 4 resistance each of 1 by 2 ohm is, we know that we get the maximum resistance of the system of resistors when they are connected in series. Whereas in case of parallel connection, the total resistance will be decreased. So in order to get maximum resistance, we have to connect these resistors in series. What happens when these resistors are connected in series? The total resistance Rs is given by sum of the individual resistances. That is R1 plus R2 plus R3 plus R4. Here there are 4 resistors, each of 1 by 2 ohm. That is half ohm. So I will get the total resistance as 2 ohm. It is equal to 2 ohm. The right answer is A, that is 2 ohm. What is meant by potential difference between 2 points? We know that how do we define the potential difference? It is the amount of work done in moving a unit charge from one point to another point. For example, if we are measuring the potential difference between these 2 points, then how do we define it? It is the amount of work done in moving the unit charge from A to B, which will give us the potential difference between these 2 points. So, let us define the potential difference here. The potential difference between 2 points defined as the amount of work done in moving unit charge from one point to another, and it is given by V is equal to W by Q. W is the amount of work done in bringing unit charge from one point to another. Q is the charge here. Now, next question. Write the relation between the current, that is electric current I, passing in a conductor, charge Q, flowing in the conductor in time t. We have to write the relation between these quantities. We know that electric current is the rate of flow of charges, and it is given by the formula I is equal to Q upon T. I is the electric current here. T is the time for which the charge Q flows. It is the time, and Q is the charge. This is the relation between current I, electric current I, charge Q and the time T. The next question is state Joule's law of heating. It is asked many times in the examination. What does this law state? It states that the heat produced in the resistor is directly proportional to the square of electric current, and it is directly proportional to the resistance for a given current, and it is directly proportional to the time for which current flows in the electric circuit. So let's write the law, that is Joule's law of heating. The heat produced in the resistor is directly proportional to the square of electric current, and it is also directly proportional to the resistance for a given current, and it is directly proportional to the time for which the electric current flows. So this implies H is directly proportional to I square. H is directly proportional to R, that is resistance. More the resistance offered, more will be the heat produced. And heat is also directly proportional to the time for which current flows. Now, the mathematical form of this Joule's law of heating is given by H is equal to I square RT. This is the mathematical form of Joule's law of heating. The next question is, draw a schematic diagram of a circuit consisting of battery of two cells, each of 1.5 volt, 5 ohm resistor, 10 ohm resistor and a 15 ohm resistor and a plug key, all connected in series. We have to draw the circuit diagram for this. They have given 3 resistors here. We have to draw 3 resistors. A battery consisting of 2 cells of each 1.5 volt is connected. We have to show here 2 cells. And also plug key is connected. These are the resistors connected in series. And what is the value of these resistors? It is of 5 ohm. This is of 10 ohm. And this is of 15 ohm. All connected in series. And also plug key is connected in series. This battery has 2 cells, each of 1.5 volt, which means the total voltage will be 3 volt. We have to show the direction of current here. It is always shown opposite to the flow of electrons, that is from higher potential to lower potential. So this is the direction of current. This is how we will show the schematic diagram for a circuit consisting of battery of two cells and the resistors having resistances 5 ohm, 10 ohm and 15 ohm. These are all connected in series. Next, the question is, why do electricians wear rubber hand gloves while working? It is mainly due to the reason that rubber is an electrical insulator. So, in order to avoid the electrical shocks, the electricians will wear rubber hand gloves as to avoid electrical shocks, because rubber is an electrical insulator. The next question is, why are the heating elements of electric toasters and electric irons made of an alloy rather than a pure metal? Alloy is a homogeneous mixture of two or more metals or a metal and non-metal. We usually use an alloy rather than pure metals in case of electric toasters and electric irons. The most commonly used alloy is of nichrome wire containing nickel and chromium in the alloy. Now the question is, why these are made up of alloys rather than simply the pure metals? The answer is, the resistivity of alloys is greater than that of pure metals, which implies that the resistance of these alloys are greater than the pure metals. What happens if the resistance is more? Then the heat produced will also be more. And in case of these electrical devices, that is toasters and irons, we require more heating effect of electric current, because of which these are made up of alloys rather than pure metal. The heating elements are made up of alloys rather than pure metal. The answer is, the resistivity of alloys is greater than that of pure metals, which are present in the alloy. So, the resistance of such alloy is also more, and it gives, and because of that alloys produces more heat on account of heating effect of electric current. As we desire more amount of heat in these electrical devices, because of that we will use alloys in the place of pure metals. And one more reason is, these alloys do not oxidize easily. So these alloys are used in the heating elements. They can withstand even high temperature without getting oxidized. The alloys do not oxidize easily at high temperature. So they can withstand more heat than metals, as they do not get oxidized easily, which means they will not get deteriorated easily. So they can withstand more amount of heat when compared to metals. This is why alloys are used in the heating elements instead of pure metals. Next question is, how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? Let us write the given quantities here. The Potential difference V is equal to 220 volt and the total current I is equal to 5 ampere. So we can calculate the equivalent resistance or the total resistance. Let Rp be the total resistance, which is given by 220 upon 5. It is equal to 44 ohm. Now the question is, how many 176 ohm resistors should be connected in parallel in order to get the equivalent resistance of 44 ohm? Let N be the number of resistors connected in parallel to get equivalent resistance or total resistance as equivalent resistance or total resistance as 44 ohm. Now we know the formula for obtaining the equivalent resistance for system of resistors connected in parallel. The reciprocal of the equivalent resistance, it is equal to the sum of reciprocals of the individual resistances. Now we know the value of individual resistance, but we don't know the number of resistors. So let's write here 1 upon 176 plus 1 upon 176 plus 1 upon 176 plus n times, because we don't know the number of resistors connected. That we have to calculate here. Now we get 1 upon 44 is equal to n times 1 by 176. So n will be equal to 176 by 44, which will be 4. So the number of resistors which should be connected in parallel in order to get the equivalent resistance of 44 ohm is equal to 4. Number of 176 ohm resistors connected in parallel to get equivalent resistance of 44 ohm will be 4. We have shortcut formula for calculating the equivalent resistance when the resistors have the same value of resistance. Let's see here. If we are having two resistors connected in parallel having the same value of resistance. Let X be the value of resistance for both these resistors. Now the equivalent resistance is given by 1 upon Rp is equal to 1 upon X by 1 upon X. So 1 upon Rp is equal to 2 upon X, which gives Rp is equal to X by 2. This is for two resistors having the same value of resistance. X is the individual resistance value. This formula can be applied only when all the resistors having the same resistance, and this 2 is the number of resistors. So for this particular question we can apply this shortcut formula also. The equivalent resistance Rp is equal to individual resistance, that is 176 ohm upon the number of resistors that we don't know. So N will be equal to 176 ohm divided by Rp is the equivalent resistance, that is 44. We will get again the 4. This will get cancelled and 44 4s are 176. So the number of resistors will be 4. The next question is, what is electrical resistivity? State the SI unit of resistivity. The electrical resistivity is defined as the resistance offered to the flow of current by a conductor of unit length and unit cross-sectional area. The electrical resistivity is defined as the resistance offered to the flow of electric current by a conductor of unit length and unit cross-sectional area. We know that the resistance is given by the formula R is equal to rho L upon A. When the length is 1 meter and area is 1 meter square, then we get rho is equal to R. So, this electrical resistivity is defined as the resistance offered to the flow of electric current by a current of unit length and unit cross-sectional area. This will be equal to resistance when there is length is 1 meter and area of cross-section is 1 meter square. We get rho is equal to R. And they have also asked the SI unit of resistivity. The SI unit of resistivity is ohm meter. The next question is the voltage current graph of a metallic conductor at two different temperatures T1 and T2 is shown in figure. At which temperature is the resistance higher? These are the two graphs for the metallic conductor at two different temperatures. We have to find out for which temperature is the resistance higher. We know that slope is equal to V upon I for this graph, which is equal to R, which implies more the slope, more is the resistance. Among these two graphs, which one is having higher slope? For the conductor at temperature T2, it is having higher slope, which implies the resistance for this conductor at temperature T2 is more. Hence, the conductor at temperature T2 is having higher resistance. How did we find out this? By comparing the slope. Among these two, this one is having the higher slope. We know that more the slope, more will be the resistance for this graph. So as this is having the higher slope, the resistance of the conductor at this temperature T2 will be higher. The next question is define Ohm's law. It is asked many times in the examination. This Ohm's law gives the relation between the potential difference and the current flowing through a conductor. What does it state? It states that the potential difference across the conductor is directly proportional to the current flowing through the conductor, provided the temperature and other physical conditions remains the same. So, the potential difference across the ends of the conductor, given conductor, is directly proportional to the electric current going through the electric circuit, provided the temperature and other physical conditions remains the same. It is very important to mention that the physical conditions and the temperature should remain same. Then only the resistance will be constant. What is the mathematical form of this law? V is directly proportional to I. V is equal to IR, where R is the proportionality constant. It is called as resistance. And it is constant for a given metallic wire at constant temperature. When the temperature changes, this R will also change. So it is important to mention that the temperature should remain constant. Then only the Ohm's law will hold good. R is constant for a given metallic wire and at a given temperature. The next question is define electric power and write its SI unit. We know that electric power is the rate of consumption of electrical energy, or it is also defined as the rate at which electrical energy is dissipated or consumed in an electrical circuit. So, electric power is defined as the rate at which electrical energy is dissipated or consumed in an electrical circuit. And also they have asked to write the SI unit. We know the SI unit of electric power is watt. The next question is, in a network of resistors as shown in figure, calculate the equivalent resistance between the points S and R and P and R. We have to calculate the equivalent resistance in these two cases. First, let us calculate the equivalent resistance between the points S and R. Equivalent resistance between the points S and R. When we consider the equivalent resistance between S and R, these network of resistors can also be drawn as between S and R. These three resistors are said to be connected in series, and these three resistors are in parallel with this resistor. When we consider the resistance between the point S and R, this is of 3 ohm, this is also of 3 ohm, and this is also of 3 ohm. It is also having 3 ohm resistance. Now we can easily calculate the equivalent resistance between these 2 points. First, let us calculate the equivalent resistance of these 3 resistors. The 3 resistors of 3 ohm are connected in series. So, the equivalent resistance of these 3 resistors will be equal to 3 ohm plus 3 ohm plus 3 ohm. It will be equal to 9 ohm. Now these three system of resistors are said to be in parallel with this resistor. So it can also be represented now as it is of 9 ohm when we consider this overall resistance. This is of 3 ohm. Now it is easy to calculate the equivalent resistance when these two resistors are connected in parallel. So now equivalent resistance between the points R and S is equal to 1 by Rp is equal to 1 by 9 plus 1 by 3. It will be equal to 1 by, it will be equal to 9, 1 plus 3 is equal to 4 by 9. So 1 by Rp is equal to 4 by 9. So Rp is equal to 9 by 4, which is equal to 2.25 ohm. This is the resistance of, this is the equivalent resistance between the point S and R. Now let us calculate the equivalent resistance between the point P and R. When we consider these 2 points, then the network of resistors can be represented as like this. In this way, these two are connected in series, these two are connected in series if we consider between the points P and R, and these system of resistors are in parallel with this system of resistors. Now we will calculate the equivalent resistance in this case. Equivalent resistance between the points P and R. Now the system of resistors can be represented as, this is the point P and this is R. We have 3 ohm resistance for all these resistors. Now let us calculate the total resistance for this series connection and also for this series connection. The equivalent resistance to 3 ohm resistors in series is equal to 3 ohm plus 3 ohm is equal to 6 ohm. These two are connected in series and these two are connected in series. So we will get the total resistance for this 6 ohm and also for this 6 ohm. So this can be represented as, these two are connected in parallel. Now 2 6 ohm resistors are connected in parallel. So now equivalent resistance between the points P and R is equal to 1 by Rp is equal to 1 by 6 plus 1 by 6 is equal to 2 by 6. Rp is equal to 3 ohm. For this case, Rp is equal to 3 ohm, which means the total resistance between these 2 points. The total resistance between these 2 points is equal to 3 ohm. Next question is, derive an expression for the equivalent resistance of 3 resistors of resistance R1, R2 and R3 connected in series by drawing suitable diagram. First, let us draw the circuit diagram for this. The 3 resistors of resistances R1, R2 and R3 are connected in series. Ammeter is connected to measure the current. This is battery. A plug key is connected. The voltmeter is connected to measure the voltage. The direction of current is shown here. These 3 resistors having resistances R1, R2 and R3. Now let us derive the equation. Take 3 resistors R1, R2 and R3 connected in series. A battery of V volts has been connected. Now we know that the potential difference across each resistor is different. How will we measure the potential difference across each resistor? We will connect voltmeter across each resistor and we will find out the potential difference across each resistor. So let V1 be the potential difference across R1, V2 be the potential difference across R2 and V3 be the potential difference across R3. It is found that the total potential difference across these resistors is equal to the sum of individual potential difference. So that V is equal to V1 plus V2 plus V3. The total potential difference across the resistors, that is 3 resistors, is equal to the sum of individual potential difference. And it is equal to the voltage of battery. Suppose if I replace the system of these resistors by an equivalent resistor such that the same current I is flowing through it and the potential difference is V volt. Then applying Ohm's law to that circuit, we get V is equal to I RS, where RS is the equivalent resistance. It is equal to applying Ohm's law for each resistor, we will get V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. As these are connected in series, the same current I is flowing through the circuit. Now taking I as common, we get R1 plus R2 plus R3. These two gets cancelled. So the equivalent resistance will be equal to R1 plus R2 plus R3 when these resistors are connected in series. The next question is calculate the equivalent resistance of the following network. Here these two resistors are connected in parallel and this system of resistor is connected in series with this resistor. First let us find out the equivalent resistance of these two resistors. The total resistance of 20 ohm and 20 ohm connected in parallel is equal to 1 by Rp is equal to 1 by 20 plus 1 by 20. So 1 by Rp is equal to 2 by 20. So Rp is equal to 10 ohm. Rp is nothing but it is the total resistance of these two resistors. Now again this system of resistor is connected in series with this resistor. So our equivalent resistance in this case will be Rs is equal to 10 ohm plus Rp. That is Rs is equal to 10 ohm plus 10 ohm is equal to 20 ohm. Rs, it is the equivalent resistance of this resistor 10 ohm and this system of resistors. So total resistance of the network is equal to 20 ohm. Question is which uses more energy? A 250 watt TV set in hour or a 1200 watt toaster in 10 minutes. First let us calculate the energy consumed by TV set. For TV set P is equal to 250 watt. It is equal to 250 upon 1000 kilowatt. And time T is equal to 1 hour. So electrical energy consumed is given by is equal to P into T, which is equal to 250 by 1000 into 1. It is equal to 0.25 kilowatt hour. Now let us calculate the electrical energy consumed by toaster. For electric toaster, power P is equal to 1200 watt, which is equal to 1200 divided by 1000 kilowatt. And time is equal to 10 minutes. Converting it into hour, we get it is equal to 10 by 60 hour. So, electrical energy consumed is equal to 1200 divided by 1000 into 10 by 60 kilowatt hour, because electrical energy consumed is equal to power into time. So solving this, we will get 12 ones are 12 fives are. It will be 1 by 5, which is equal to 0.2 kilowatt hour. So the more electrical energy is consumed by TV set when compared to toaster. The TV set consumes more electric energy than toaster. This is our answer. Now the next question is, the current flowing through a resistor connected in a circuit and the potential difference developed across its end are shown in the diagram by milliammeter and voltmeter readings respectively. We have to find out what are the least counts of these meters and what is the resistance of the resistor. What do you mean by least count? It is the smallest value that the device can measure. How can we find? Let's see here. Between these two readings, the difference in the current is 100 milliampere. 200 minus 100 is equal to 100 milliampere. And between these two readings, there are 10 divisions. So, for one division, what is the value? Let's see. Least count for milliammeter. So, this shows that 10 divisions is equal to 100 milliampere, because the difference between these two is 100 milliampere and there are 10 divisions in between these two readings. So, that 10 divisions is equal to 100 milliampere. What is the value of one division? One division is equal to 100 by 10 milliampere. It is equal to 10 milliampere. This is the least count for milliammeter. Now, what is the least count for voltmeter? What is the difference between these two readings? 2 minus 1. It is equal to 1 volt. 2 volt minus 1 volt is equal to 1 volt. In between these two readings, there are 10 divisions. So that 10 divisions is equal to 1 volt. So 1 divisions is equal to 1 by 10 volt. It is equal to 0.1 volt. So the least count for voltmeter is equal to 0.1 volt. And for ammeter, the least count is 10 milliampere. Now they have asked again to find out the resistance of the resistor. Let's see here. We have the potential difference and current shown in these diagrams. See here, up to here the current is 200 milliampere, and after this there are 5 divisions here. 1, 2, 3, 4, 5, which means 200 milliampere plus 50 milliampere. Why 50? Because one division is equal to 10 milliampere. 10 into 5 is equal to 50 milliampere. So, the current I is equal to 200 milliampere plus 50 milliampere is equal to 250 milliampere. Now, let us find out the potential difference. V is equal to, up to here, the voltage is 2 volt. After this, there are 4 divisions here, such that one division is equal to 0.1 volt. So, we will get total voltage at this point is equal to 2 volt plus 0.4 volt is equal to 2.4 volt. Now, we have find out the current and voltage from these diagrams. We can easily find out the resistance. So, R is equal to V by I. What is the V? Potential difference 2.4 volt by current 250 milliampere. We have to convert this milliampere into ampere. 2.4 volt by 0.25 ampere. It will comes out to be 9.6 ohm. So this is the resistance. The next question is two lamps, one rated 100 watt 220 volt and the other 60 watt 220 volt are connected in parallel to electric mains supply. Find the current drawn by two bulbs from the line if the supply voltage is 200 volt. First, let us calculate the current drawn by the first bulb. Let P1 be the power of the first bulb, which is equal to 100 watt, and the voltage V is equal to 220 volt. Now we know that P power is equal to V into I. To calculate the current, we have I1 is equal to P upon V. I1 is the current drawn by the first bulb. It is equal to 100 divided by 220. 0, 0 cancels. 2 5s are 2 11s are. 11 zeros are 11 4s are 44. 11 5s are 55. So we will get 0.45 ampere for first bulb. Let P2 be the power of second bulb, which is equal to 60 watts. And the voltage V is equal to 220 volt. Now we have to calculate the current drawn by. I2 is equal to P2 upon V. Here we have to write P1, which is equal to 60 divided by 220. 2 3s are 2 11s are. 11 zeros are 11 2s are 22. 11 7s are 77. So we will get 0.27 ampere. So the total current drawn by these two bulbs from the main source will be equal to I is equal to I1 plus I2. It is equal to 0.45 plus 0.27. It comes out to be 0.72 ampere. So the current drawn by two bulbs from the line is equal to 0.72 amperes. So the current drawn by the two bulbs from the line is equal to 0.72 ampere. The next question is, you have three resistors of R ohm each and a battery of E volts. How would you connect these resistors with the battery to obtain maximum current, and draw a circuit diagram to illustrate your answer and also calculate the current drawn from the battery? They have asked how can we connect these resistors in order to get the maximum current. We can obtain the maximum current only when the resistance is low. For parallel connection, we have the total resistance or equivalent resistance having lower value. In that case, we will get the maximum current. But if we connect it in the series, we will get the maximum resistance but less current. So, the resistors should be connected in parallel to obtain maximum current, as total resistance in parallel connection decreases, which is responsible for flow of larger current. Lesser the resistance, more will be the current. More the resistance, lesser will be the current. So here in case of parallel connection, the total resistance or the equivalent resistance will be decreased. Because of that, it will draw the maximum current. Let us draw the circuit diagram for this. They have given 3 resistors of R ohm each and a battery of E volts are connected. They have given the 3 resistors of R ohm each and a battery of E volts are connected in the circuit. So let us draw it. As we are connecting these resistors in parallel, we are showing in this way. In this case, we are going to get the maximum current. This battery is having the voltage of E volts. These are having the resistances R ohm. All these are having resistances of R ohm. This is the direction of current. Also, they have asked to calculate the current drawn from the battery. We know that in case of parallel connection, we can calculate the equivalent resistance from the formula 1 upon R is equal to 1 upon small r plus 1 upon small r plus 1 upon small r. Because R is the resistance of all these resistors. So we get 1 upon R is equal to 3 by R. Therefore, R is equal to R upon 3. Now we have V is equal to E volts. And to calculate the current, we know that I is equal to V by R. So I is equal to E by R by 3. So I will be equal to 3E by R. The next question is, although electric kettle and electric toaster were used simultaneously in the kitchen to prepare breakfast for the family, yet the two devices could work efficiently due to fuse used in electric circuit. What is fuse? Write the material used in fuse wires. How is fuse connected in an electric circuit? We know that fuse is an electric device which protects the circuit and other appliances by stopping the flow of current when there is large excess of electric current flowing through the circuit. That is, when there is any unduly high current flowing through the circuit. How will it protect? The fuse consists of a wire which is made up of a metal or an alloy having the appropriate melting point. When there is large excess of current, more than the specified value passes through this fuse wire. What happens? The temperature of the fuse wire will get raised. Because of that, it will melt and the circuit will be broken. Because of that, it will prevent the short circuit. So, electric fuse is a device used to protect circuits and other appliances by stopping the flow of unduly high current, electric current, and it works on the principle of Joule's law of heating. Also, they have asked here, write the material used in fuse wires. How is fuse connected in an electric circuit? The material used in fuse wire is made up of either metal or an alloy consisting of metals like iron, lead, aluminium, copper. These alloys or metals which is used in fuse, it is having the appropriate melting point. When more than specified amount of current flows through the fuse wire, it will get heated and because of that it will get melted. Fuse wire is Fuse wire consists of piece of wire made up of metal or an alloy of appropriate melting point. For example, aluminium, iron, lead, copper, etc. Now they have asked to write how is fuse connected in an electric circuit. Fuse is always connected in series with the device. Fuse is always connected in series with the device. What is the main aim of connecting the fuse? When there is large excess of current flows due to any voltage fluctuation, it should break the circuit. In order to break the circuit, that fuse must be connected in series with the device. Otherwise, if it is connected in parallel, then circuit will not be broken. What happens if the fuse is connected in parallel with the device? Even though the wire which is present in fuse breaks, the circuit will not break, as in parallel connection the path of current will be different, so it will not prevent any short circuit. So always this fuse is connected in series with the device. Again, there is one more question here. State the ratings of fuse used in electric circuits. The rating of fuse is the maximum current which can flow through the fuse without melting the wire that is present in the fuse. Second answer is the rating of fuse is the maximum value of current flow through it without melting the fuse wire. And the fuse used for the domestic purposes, they are rated, and the fuses used for domestic purpose, they are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere and 10 amperes. In this way, the fuses used for domestic purposes are rated as 1 ampere, 2 ampere, 3 amperes, 5 amperes and 10 amperes, etc. Suppose if the fuse has the rating of 2 ampere, 2 ampere of current can flow through this fuse without melting the fuse wire. If more than this specified amount of current flows through that fuse, then the melting of that wire will takes place, which will cause the circuit to break down. So these are some important questions and PYQs including the numericals of the chapter electricity.